Pythagorean theorem. In this video, you will learn what the Pythagorean theorem is, how to use it, what it tells us, and the words associated with it. The Pythagorean theorem, which was named after the Greek mathematician Pythagoras, shows the relationship between the sides of a right triangle. The most important piece here is that it can only be used for a right triangle, not any triangle. A right triangle is a triangle with a right angle inside. We know that we couldn't have more than one right angle because the three interior angles of a triangle always add up to 180 degrees. So we couldn't have two right angles because that would be 180 degrees since a right angle is 90 degrees. Here I have a right triangle. I know that it's a right triangle because I see the right angle symbol down in the corner. The two sides that form the right angle, or the two sides that are perpendicular to each other, are called the legs. The side across from the right angle is called the hypotenuse, and the hypotenuse is always the longest side of the triangle. Remember that these words, leg and hypotenuse, are only true for right triangles. The Pythagorean theorem tells us that if we call our legs A and B, and these are interchangeable, and we call our hypotenuse C, that the length of A squared plus the length of B squared equals the square of the length of C. You'll see this formula probably throughout your life. A squared plus B squared equals C squared. Again, this only holds true for right triangles where A and B are the interchangeable legs and C is the hypotenuse, or longest side, the one across from the right angle. Now let's look at some questions that you may see related to the Pythagorean theorem. One type of question will say, can you make a right triangle with the given side lengths? You may remember from last year that in order to make a triangle, just a triangle in general, you need to have the two smaller sides add up to longer than the third side. That allows you to close the three-dimensional figure. But in order to make a right triangle, we have to have the relationship A squared plus B squared equals C squared. So the sum of the squares of the two smaller sides must add up to exactly the square of the third side, which is the longest. Let's look at these two examples together. We want to know if A squared plus B squared equals C squared. So I'm going to label my 6A and my 8B and my 10C. I did this because my 10 is my longest side. It didn't matter if I labeled 6A or B and 8A or B, because again, the two shorter sides, which are the legs, are interchangeable. So I want to know, is 6 squared plus 8 squared equal to 10 squared? And notice that I put a little question mark above my equal sign because I'm not saying that they're equal yet. So is 36 plus 64 equal to 100? It is. So therefore, yes, it is a right triangle. Let's do a second example. I again am going to label my two shorter sides, A and B, and my longest side, C. And I want to know if 8 squared plus 4 squared equals 9 squared. Because if this is a right triangle, which is what it's asking, then A squared plus B squared must equal C squared. Remember that these both do form a triangle, and I know that because the shorter sides, 8 plus 4, is greater, or 12, is greater than 9. But I'm asking if this forms a right triangle, in which case my relationship has to hold. I get 80 equals 81, so I do not have a right triangle. Now the angle is probably very close to 90 degrees, because 80 equals 81 is so close together, but we know that 80 does not equal 81. The next type of problem you might need to do is to find the missing side length in each right triangle. Remember that our relationship only holds for a right triangle, so you need to look for the little 90-degree symbol in the corner to indicate that it is, in fact, a right triangle. We'll do two examples together. I start each example by labeling my sides so that I know what I'm looking for. In the first example, I know that I'm given the two legs, so I'm going to label them A and B. And I'm missing my hypotenuse C. I always write the formula first and then fill in what I know. So I have 12 squared plus 35 squared equals C squared. Although these are all positive values, so the parentheses don't make a difference, it's still a good habit to be in. For some of these, you'll already know the value. For example, 12 squared is 144. But for others, you'll need a calculator. 35 squared is 1,225. So in order to solve this equation, I first need to add my 144 with my 1,225 to get 1369. And I have 1369 equals c squared. I know that in order to solve this equation, I take the square root of both sides, and I remember to put positive and negative. Even though in this case we cannot get a negative side length, this is still a good habit to be in. So I get positive and negative 37 equals c squared. And I can either make a note, or in my head I know that I can't actually use the negative, so I can get rid of it. And our answer is 37 centimeters. That means that my missing side length here was 37 centimeters. And I could check this by now taking all of my sides. 12 squared plus 35 squared should equal 37 squared. Now again, the reason why I did the positive and negative is because that's how you would properly solve this equation. I even put my positive and negative here, but I got rid of the solution that didn't make sense, the negative, because we can't have a negative side length. And the positive is my answer. I would do this anyway, just so you don't get in the habit of only putting the positive answer. Let's look at a second example. In this example, one of my legs is given, so I'll call it A. My second leg is not given, so I'll call that B. And my hypotenuse is given, so I'll call it C. I set up my equation, a squared plus b squared equals c squared, just like always. So I have 24 squared, again using parentheses, plus b squared equals 25 squared. I'll use a calculator or do some scratch work to the side. So I have 576 plus b squared equals 625. I have to move the 576 to the other side of the equation before I can do the square root if I'm looking for b squared. And I get b squared equals 49. You may be able to do the rest in your head, but I'll still show it out. I take the positive and negative square root of both sides in order to get that b equals positive or negative 7. I know that the negative doesn't make sense because I'm looking for a side length, and therefore I get that my missing side is 7 inches. Don't forget the inches, just like we remembered centimeters for the last example. As you do more and more work with the Pythagorean theorem, you'll start to see some common sets of 3 side lengths that form a right triangle. We call Pythagorean triples the integer solutions to the Pythagorean theorem. Some common sets that you'll see are 3, 4, 5, 5, 12, 13, and 8, 15, 17. This can be useful because sometimes you'll see a triangle with a missing side like this, and you'll know, oh, well the last side there has to be a 5. Similarly, you may even see multiples of these. So you may see 15 and 12, and you know, well, the 15 is 3 times our common hypotenuse of 5. The 12 is 3 times our common leg of 4, and therefore this missing side is 9. This may be a stretch for you at this point, but you'll start to see and notice these patterns, and it will help you check your work later on. Bye. Have a nice day.